Before I go in, let me just mention something that a few of you may not know. Massachusetts was a mediocre state in terms of achievement about 15 years back. Around middle of 2000s, 2003, 4, 5, it became the first in the nation, all the tested subject, and stayed there. And clearly the work that was done by Dr. Stolsky and others in Massachusetts was successful and an example to many of us. Okay, I will talk about math standards, and I will try to go fast. You notice my accent, I'm sure. This is not California accent, by the way. It's a weird accent, but I hope you will understand me. Who wrote them? And Dr. Stolsky mentioned the people that wrote the language standards. Here there were three main writers. One mathematician from University of Arizona, college mathematician, who has very limited experience in writing standards before just for Arizona. Jason Zimba, who is a physicist from a college in Bennington. And Phil Darrow, who is an English major. Those were the three people that essentially ruled the writing of the standards. There was a support team that is often called in. Oh, there are tons of other people. Yes, most of them were testing people, administrators, some mathematicians, some teachers, and they could throw in suggestions over the internet. There were 1 or 2 meetings of the group, but all the rest was done through the internet. They would send a suggestion. There was never a feedback. Some of them will adopt the suggestions, some were not. There was never, each draft that came around, there was never a summary of what changed and why it changed. Again, the process was very opaque. There was also a feedback team, it was even more remote. There were more mathematicians there. But again, they would submit their comments because there was some non-public draft that states and this feedback team got. And there was never a feedback. There was a new version a month down the line, and you didn't know exactly what changed, why it changed, what is the reasoning. Nobody voted on the reason. The three guys ruled the team. So when they say, oh, there were mathematicians on the teams and they were vetted by many, no, they were not. The experience on the writing team was minimal, and the results show it. The claims are very similar to both English and math. All they are rigorous, coherent, clear, internationally benchmarked. They are anchored in college and career readiness, and they are evidence and research-based. And you see it from many people. Other people quote it and parrot it even. I mentioned here Bob Wise, that are clear, consistent, compete with peers around the state line and across the ocean. You hear it from National PTA, from National Council of Teachers of Mathematics, Council of everybody. Everybody was paid by Gates, by the way. But let's see, though, are they all these things? And, you know, I can do three things. I can tell you what I think of them, which effectively I'm going to do, but not in my words. Because why should you trust me? I mean, I'm a nice guy, I talk fast or weird accent, but am I right? Who knows? Maybe yes, maybe no. I can go into details, but you will be bored to this very quickly. Well, I will try to use the people that are closest, that wrote them, that should know, and not typically on my side. So, here is a guy who was running an education journal, Rick Hess, very famous in Washington, very smart, Harvard grad, very prolific. And he was trying to put together basically a pro and con forum in Education Next, which is a monthly magazine, a quarterly magazine, not monthly. And here he said, look, I tried to get these guys to defend the Common Core, and I couldn't find anyone who would stand up and is willing to take a real discussion as opposed to just jingoistic PR over the page of the internet, of the media, which is paid for by Gates. I couldn't find anyone. Finally, they found a guy who is a very nice guy, but he was not really so much for pro-Common Core, because nobody for pro-Common Core go. Here is the guy from the College Board, who is in charge of the AP courses. Well, he says, AP Calculus is in conflict with the Common Core. It lies outside the sequence because it feels it may unnecessarily rush students into advanced math. So this is supposed to be a rigorous set of standards. Suddenly they cannot support AP Calculus anymore. Oh, and here is the actual main author, Bill McCallum, the mathematician from Arizona. He was talking in front of annual conference of mathematical societies, the AMA and AMS. The overall standards would not be too high, certainly not in comparison to other nations, including in Asia and so on and so forth. Whoops, that's not my word. This is the author. Oh, this is an example from this discussion. They are supposed to be clearer. Well, here are standards of California about division. So in grade 4 in California, the development goes, solve problem involving division of multi-digit number by one-digit number. Okay, something. Look at the corresponding standard in the Common Core. It's supposed to be clearer. Find whole number quotient and remainder with up to 4-digit dividends and one-digit divisor using strategies based on place value, the properties of operation, and or the relationship between multiplication and division, illustrate and explain the calculation. What's clearer here? And I don't want to read the whole page. I mean, come on, are they clearer? Just read the bloody thing. Sorry, I'm not supposed to use this word. But it's hard to read them. Dr. Stolsky was right. Those are not documents you read for your pleasure. It's hard slog. You have to understand what you're reading. You have to do some comparison to understand how other people did it. It's very difficult to read. Most people are not skilled. Therefore, taking, 3 guys with very limited experience in writing standards and expecting them to come with exemplary piece of work is madness. It would never happen. And it didn't. Okay, Jason Zimba, he was mentioned already by Dr. Stolsky. The concept of Common Core college readiness is minimal and focuses on non-selective colleges. In other words, colleges that don't care about your score, community colleges, that's probably fine for them. Or you want to go to some more selective college? Think again. So that's what the career readiness you think is a parent of? I doubt it. And here is the vice president of PART, the consortium. How we will test them. Students who earn the college and career readiness determination will have demonstrated knowledge, skills, practices to succeed in entry-level college algebra. What is college algebra? Oh, college algebra is basically high school algebra given in college. That's what college algebra is. It's effectively algebra 2 given in college because somehow you didn't learn it in high school. And if you take it as a freshman course in college, your chances of doing any STEM career is close to 0. Very simple. If you start from any science or engineering course, you'd better start with college math calculus. Now, many people today take it in high school college, but that will probably go away anyway under this Common Core, as you heard just from the College Board Vice President in charge of the AP Calculus. But even in college, your entry is guaranteed only for college algebra, quote unquote, not for calculus. So forget about going to college, to STEM. Internationally benchmarked, supposedly. Original claim that the Common Core, when it started, promised was there will be internationally benchmarked. Once they realized that it's hard to argue with that, they say, oh, they are informed by international standards. However, people did look at the standards and compare them internationally. And here is what Jonathan Goodman, professor of mathematics at the Comm Institute at the New York University, said, well, the common standards have significantly lower expectation with respect to algebra and geometry than published standards of other countries. And here is Jim Milgram, who was the mathematician on the validation committee of the Common Core. A large number of Common Core standards are 1, 2, or even more years behind their corresponding standards of many, if not all, of the high-achieving countries. So are they internationally benchmarked? But they say yes, oh yeah, they're rigorous, internationally benchmarked, they are deep thinking. Well, these are people that are supposed to know. Those are people that were on the inside. Those are some of the authors testifying about their own standards. And here is Andy Porter. He's a dean of Graduate School of Education at Penn, at the University of Pennsylvania. He did a research on comparing standard issued internationally, so then he did it also for the Common Core. And he found the results surprising. High-performing countries' emphasis to perform procedures ran counter to the widespread call in the United States for greater emphasis on higher-order cognitive demand. Now, let me parse it for you. Sandy was mentioning before, how do you learn critical thinking? You don't learn critical thinking any other way than by reading literature, deep literature, because you have to read between the lines. Informational text, you have to understand what you're reading, but they don't try to hide the information. In fact, they try to explain the information, so they often lower the vocabulary. So they're not trying to hide it. There's nothing to read between the lines, you have to understand, but not to read between the lines. Cognitive thinking, the critical thinking mathematics, you don't get by telling somebody, okay, today we are going to learn critical thinking. No, you do it by practicing problems, deep problems, different problems, interesting problems, sometimes boring problems, and that's how you develop critical thinking. Not by the teacher saying, they teach critical thinking is on our topic. Yeah, right. And that's exactly what the other high-achieving countries do. But those standards don't. They talk about critical thinking left, right, and middle. They talk about deep understanding. But they don't develop it. But then the Common Core people have actually one good research that's supposed to show that indeed the Common Core is research-based, and it is in line with other countries. And it's done by Professor Bill Schmidt of Michigan, rather famous. He was a coordinator of a third International Math and Science study, TIMSS, in 1995 here in the US. And he recently did a study, and he came up and he said, look, the Common Core standards are very consistent with the world top achieving countries. States that have similar standards to the Common Core did the best on the NAEP, on the National Achievement of Education Progress. The Common Core is coherent and hierarchical. Well, people use it as a reference. Schmidt said, and Schmidt is a good name, supposed to know what he's talking about. So let's see what he's talking about. This is a paper that he published November last year, 7 months ago, in the leading journal of the American Education Research Association. It's called the American Education Researcher. And it starts with, indeed, the study that Professor Schmidt did 15 years ago about the high-achieving countries on the TIMSS, on the Several International Math and Science. They took the 6 high achievers in TIMSS, we call them the A-plus countries, and they looked at their curriculum, analyzed them, Schmidt and his people, and they came up with this table. This is his table from 1995 that he's also using in this recent article. And what you can see here is basically you have the rows are various topics in the elementary grades, grade 1 through 8, and on the columns you have the grades 1 through 8. And anywhere you have a dot and a shaded together, come together, this is a topic that is taught in the majority of those A-plus countries. And if you look, this table is very logically arranged. It starts with early grades with whole number meaning and whole number operations, starts with grade 1 and goes for 4 or 5 years. And then it goes, to 2D geometry basics, somewhere in the second group, starts in grade 3, goes for a few years. Then somewhere down below, almost at the bottom, you say 3D geometry down at the bottom. It starts in grade 6 and 7. Those are the normal way you would teach. And indeed, you see this shape that the topics, some topic starts early, no topic almost goes throughout. So you teach them and you stop. You don't teach them forever. You don't repeat it. That's considered an example of cohesive curriculum. It makes sense. Early topic, easy topic show up there on the top. More advanced topics show on the bottom. You have the triangular shape. This is how you would judge a curriculum to be cohesive, focused. Good. And here is the second table that Professor Schmidt did that shows how the Common Core plays on the same list of topics in principle. And you see the shape is kind of similar. Well, you see some topics go through all the 8 years rather than in the first table that no topic really went for all the 8 years, but overall they kind of look similar, right? Well, there is a problem. First, this is what Professor Schmidt in his paper says. After presenting the second table, he says, we note that figure 2, which is the second table, representing the Common Core, bears a strong resemblance to figure 1, the A1, A+ model, at least in terms of its general shape. From that point of view, we can say it can be suggested that the Common Core are coherent and focused. That's exactly what he says. He writes it in the leading journal of American Educational Research Association. Let's go back to the table. If you look at the table on the right, the second table, you may notice that the orders of the rows have changed. He reshuffled them to get the same shape. So suddenly, 3D geometry is here. Not up here, down here, it's suddenly up here. In fact, 2D geometry starts after the 3D geometry. So yes, he rearranged it so it looks triangular, except that suddenly the topics are in completely different order, but the shape is the same. Wow! Don't play poker with this guy. Now, he didn't stop that. He eventually said, journal, you have to be serious. So let's put them together. Here is a table that we put them together. So the gray background is the Common Core, now in the order of the Common Core. And the dots are the original table 1, which is where the A+ countries are. Well, they're not exactly the same, but triangular shape is there because we see it kind of jumps out. Kind of. Except that if you actually highlight the themes, now you see, oh, there is no rhyme and reason. It's visually, the shade kind of overtake you. So you don't see the dots so much, how they are actually unaligned now under the new order. But if I added the red on top of it just to highlight the dots, oh, where is the triangular shape? Where is the order? Where is the rhyme and reason? Oh, but they look the same. Okay. And here is the final conclusion after the table. There being no major difference between the two sets of standards, this provides further evidence that the Common Core are coherent and very consistent with the international benchmark. Wow! How can he say that? Well, he did. Overall, he also said the congruence, the alignment between the two, is very high. It's 85% congruence. And I kind of count the squares, and you have to count it later if there's a hard copy if you can. There are 131 squares that are filled here between the rows and the columns. 45 of them are in Common Core and not in the A+ countries. 15 of them are in A+ and not in Common Core. 60 out of the 130 are not there. That's 50% almost unaligned. 85%. He's a statistician. I don't know how he counts. And to make it worse, he coded the standard. I mean, how did you make the original table? I mean, the second table, not the original. He took the Common Core, right, and said, oh, this belongs to this topic. This standard belongs to that topic. And he gave graduate students the job to do it. However, it's hard to believe that standards, say, measurement, estimation, and error that Common Core puts in grade 2 and 3 are the same as the Japan or Korea put in grade 7. The error and estimation that they do in grade 7 is not the same kind of estimation they do in grade 2, unless you think we had Einstein's 100% Feinstein in our classrooms. Same thing about number theory. Things about rational numbers and how numbers behave under transformation. Common Core teaches in grade 2 and 3 and 4 and 5. These Asian countries teach it in grade 7 and 8, but they say, oh, it's the same. Even worse, on the bottom you see there is constructions using straightedge and compass. Read the Common Core. It's done only in high school, not in grade 7, as he says here. He misinterpreted the standard, the Common Core standard. In grade 7, what Common Core does, it's using protractor and ruler, not a straightedge and compass. Just draw it straight line. He has systematic counting, which is combination and permutations. It's a high school topic in Common Core, but he put it that Common Core does it somehow in grade 7. The people that coded the standard didn't know what they were doing. They're incompetent. This is the only paper that finds support for Common Core in research to international benchmarking and high quality and focus and rigor. And this is what the Common Core proponents bring. Oh, but there is research supporting from Professor Schmidt. He is of the team's fame, indeed. I think that the fame is going away at this point. This is a terrible paper. I don't know how it was approved, accepted. I mean, anybody can look at it. It's just a bunch of jiggle. Okay. How am I on time? Okay. I have some examples here. I want to talk to you about. Common Core people will say, a couple of examples where you want to get a sense of what's going on. Oh, you know, we teach deep and deep arithmetic, and they do a lot of focus on arithmetic. And we teach, you know, the standard algorithms, because everybody is saying, well, we don't want this fuzzy math. So yes, they teach the standard algorithm. A year late, so typically addition subtraction of integers in grade 4 instead of what most more advanced countries do in grade 3. Multiplication in grade 5 instead of 4 and such. So you say, well, what the big deal, 1 year less, 1 year more. Eventually they're supposed to be fluent in the standard algorithm. That's good enough, right? Yeah, in principle, right. Except, what do they do in the preceding years? Do they study it slowly before they have to be proficient? No. There, they study strategies and various approaches how you can understand these operations. So they fill their ears, year after year, with various ideas that may work for some particular number, may not work for other particular number, may be good to up to 2-digit, will not work probably with 3-digit. And then somehow magically, in the final grade, oh, they have to be fluent in the Common Core. No, they are confused by then what to use to add and subtract. That's the problem. So it's not that they delayed it by a year. You know what? Stuff happens. You have to make decisions. Standards are about decisions. But the problem is that they fill their minds with all these useless strategies for years and then they say, oh, by the way, you also have to be fluent in standard algorithms. Guess what? They will be not. And that's why Professor Milgram, mentioned his name, he was on the arithmetic. It's in the document itself, there seems to be a minor war going on. Because it was a political decision, we have to keep the standard algorithm, otherwise people will go ballistic. But we have to fill their mind with all the edge school rubbish because we want to. And that's what you end up with. Some major holes in kind of composition is never mentioned. So you cannot do, least common denominator. They just forgot about it. A conversion between fractions, decimals, and percents. Very key issue because it shows fluency with understanding it's the same thing. It's just how you differently represent the same fractions. So fluent conversion. And many documents recognize this is a major content of the Common Core, of the elementary maths. Common Core forgot about it. There's one minor standard that peripherally touches on it in different contexts. That's it. Only on 2 of the 3. They bring up, stuff out of the blue without build-up. So the area of triangles are very late in grade 6. Some of angles of triangle come up only in grade 8. Algebra in grade 8. This was a major, major change in the American education over the last 15 years. A lot of states made progress. I understand you have here in grade 5 decision to go to high track, low track. Well, under Common Core, algebra is high school course, period. You don't like it? Well, tough. It is anyway. But they say, well, but you know, there is a lot of algebra in grade 8. Yes, there is, some amount of algebra. In grade 7, and in grade 2, that doesn't mean that there is an algebra course. Or bits and pieces of algebra, as has been in your current standards. But algebra course, giving you a regular algebra 1 content, it's a high school course under Common Core, saying that it's more rigorous vis-a-vis what you have been doing for the last decade or more. Now, what's the big deal? The truth is, if you don't intend on going to STEM, it's probably not a big deal. But if you want to be to STEM, you want to take AP Calculus ideally if you want to go to selective colleges. And if you start in algebra in grade 9, your chance of getting AP Calculus is close to 0. And AP Calculus may not be even available because college board will say, hey, we have no takers. And those that will take it anyway will be kids that typically coming from affluent homes because they will get the extra support, extra push, extracurricular courses, and they will make it. So we'll go back 15 years where the disadvantaged kids actually were not represented among those taking algebra in grade 8. This has changed over the last 15 years. Now we're going back because only those that push themselves. We talked already about college readiness. It is not college readiness. So I will stop here on this issue, and let me switch to a different topic. Just touch on this cost of assessment very quickly. You have the ISAT. It's an online, computer-administered assessment, and it's 3 topics in grades 3 through 8 and grade 10, reading, language, and math, and it's about 90 minutes each session for a 4.5-hour total. You have also science, but that's minor, so let's not talk about it very much, because the Common Core does not offer science at this point, so this will stay as it is. And you have a testing window, I believe it's around 4 weeks. And it costs you $6 million a year, which is actually rather high. You have about 150,000 students that are tested. You have 280,000 students total in K-12, but 150 of them are in the grade that are tested. That's what you have today. You pay rather a lot, and you already have computer-based assessment, so it's actually seems like it's not, from this point of view, not going to be a major difference for you. Smarter Balance has 2 subject matter that it will test on. The same grade in elementary, 3 through 8, or elementary middle, and grade 11 rather than grade 10 in high school. Okay, you say minor difference, what a big deal. But it's almost double the testing time. Double. Instead of 4.5 hours between the topics, you get 7 to 8.5 hours between the different grades. Like the first 3 grades is 7, the next 3 grades, 5 to 8, 6 to 8 is 8, I think, and the last high school is like 8.5 hours. No, more. And it's 2 testing windows of 4 weeks each. So it's given in 2 batches. Now, imagine the impact on the school year. 2 months of the school year are basically taken away, or lightweight program, because testing is happening in the classroom. And the computers are taken for testing. They are not more in the classroom. 2 months out of 10 months of school year instead of 1 month. Huge difference. The cost is actually smaller because you already are paying through your nose truly. If you compare yourself to other states, you pay a lot for your testing. Now, how do we know the cost? Because Smarter Balance tells us, oh, the cost is about $22, $23 per student. So Smarter Balance will pay you $23 we're done. No. We will take $6. We think that it will cost you $16 to do the scoring and the report generating and everything. So you figure it out how you do it, but $16.5, it's what we think is your cost, and you take care of it. $16, is it reasonable? Well, if it's computer-based, sure, no problem. It's not expensive. But they are open-ended performance items that are free writing, takes multiple hours to write. Somebody has to score them. And there is some experience in the country. California had class test in 93, 94. Kentucky had in the early 90s a test that was open-ended. The scoring was much higher. And in fact, in the smarter balance model, the scoring of the open-ended item, the manual scoring, not the automatic testing are cheap to score. Automatic scoring, I mean. They say, oh, the teachers can do during the professional development for free. Well, is it professional development or is it a scoring session? I want to see, do you have teacher union in this state? I don't know, do you have teacher unions? I don't know. Well, I'm sure they will be happy to see that teachers are not paid for scoring. That's all I can say. So if you really do the estimation, it's much higher. It's $25 to $40 per student. And it will cost somewhere between $6 to $8 million. Okay, you say. Not a big deal in terms of difference because you're already paying high anyway. But remember, you're also doubling the testing time and you're doubling the imposition on the regular curriculum schedule. Can you take now computers for 20 times or 2 months at a time? We don't know. Now, what about the computer themselves? You already have computers, so they can be used for the new assessment. In fact, they barely meet the requirements of the computers for the new assessment. It's much more demanding than your today's assessment, but they probably can do it. But anyway, you're taking them for 2 months out of the classroom for this testing. Now, if you want to dedicate a computer, that will obviously eliminate some of it, but that will cost you about $20 million every year, not one time, every year. And if you think this is a high number, just recently, Florida, Tony Bennett went from Indiana to Florida, and he wanted to get some money for testing in Florida. Florida is a bit less than 10 times bigger than you. He wanted $600 million, one time, because this is amortized over 5 years. So this is not a big number that would cost you. So if you don't want to take the computers from the classroom because it's 2 months, well, it's another $20 million every year for about one computer for every tested student, which is about the ratio you want to use. I have some numbers how you do it, but let's not go there. So this is a testing cost summary. And remember, this is something that is out of your hands. So the cut scores, who is proficient, who is not, is out of your hand. The content of the test is out of your hand. The decision that you have today in grade 5, is the student going to continue in grade 6 on the accelerated track or not, is taken away. You're not going to have it anymore. Everybody goes in lockstep. This is coming from Washington, maybe not from the federal Department of Education, but from the Beltway robbers, as they call them. NGA, Achieve, CCSSO, and such. So, maybe this is my finishing slide here. Your state superintendent complained that the Department of Education allows now district to come directly into agreement with the Department of Education, Federal Department of Education, because he thinks it's affront to states' right that the federal feds can go directly to the district. I think he's right. But doesn't he think that enforcing the state departments themselves to do what Washington wants is also an affront to states? And I think he should think about that too. I'm done. Questions? Again, the same. ritual. There are mics in the hall, in the alleys, and the raised hands. Ask about this. There will be a Q&A period at the end for all of us, but ask about mathematics and about the cost. That's what I would like to answer right now. Don't tell me you don't know maths. Come on, you know maths. Ask.
Ze'ev.
Oh, okay.
I'm Susan Holliday, and Ze'ev is on the same loop that I'm on, so a lot of information has come from him. He is an expert, and I'm so happy you're here. My question, I have two, actually. Since we're pushed into STEM lately, a lot of the districts are using STEM so that they can establish academies and, charters and all sorts of different schools, magnet schools. How can you do STEM without higher math? And by higher math, I mean you have to go to calculus. How are we going to do that if we're going to not have
Well, the same way we do rigor. We talk about it. I'm sorry, but this is the truth. California was one of the leaders in putting kids in grade 8, if they are ready, for algebra. So we have today 2/3 of the cohort taking algebra. And the average score, by the way, have been going up as the numbers grew. So it's not like this. We have more kids taking, therefore the score dropped. No. Still not perfect. Some of them are not succeeding. But the point is, 2/3 of the cohort takes algebra today by grade 8. How it will work with Common Core, I don't know. But even worse, our state board doesn't know. They promise, we want to do it. And I believe they want to do it, except they have no bloody idea how to do it. There is no test, by the way, for algebra in grade 8. Smarter Balanced doesn't offer end-of-course tests. You don't have end-of-course tests, but we in California have algebra tests and geometry tests and algebra 2 tests. So if a student takes geometry or algebra 2 or algebra 1 early, instead of taking the grade level thing, he can take the end-of-course test. The other testing consortium, the PARC, has actually end-of-course tests, but Smarter Balance has only grade 11 tests. So if you are in grade 8, you still take algebra. Somehow you made it because you got support, you got whatever, the teacher offers it in an affluent school, whatever. You are still tested on the regular test. And by the way, people will say in California, they told me that president of the state will say, this is computer adaptive, they will ask the question in grade 8 and it will ask algebra questions if you know how to answer. Wrong. The items do not cover algebra. Smarter Balance never developed algebra items for the bank. They said it so themselves. So California has no idea how to handle it, and it has much bigger problem. You have a bit smaller problem, but you have this bifurcation in grade 6 of the tracks. It is going to disappear.
I did want to ask you, and on behalf of all of us, could we have a copy of your presentation? I would love to give this to Tom Luna, because he won't listen any other way. He is completely hostile toward anybody that's against this. And this needs to go directly to our superintendent and to every superintendent in every district in the state.
I'm a teacher by background, but my question is mostly what are the teeth in this law? That can the state get rid of it at some point if they want to, or are they somehow locked in? And how does that work?
I'm not sure I understand.
Best. Pardon?
I'm not sure I understand.
What makes the state so that they have to stay with this? Are they locked in?
Okay, I think I don't want to go into it right now, but this is a perfect question for the end period because it's a more generic question. But I will give you a 30-second capsule. There is a test and there are the standards. You can bail out of the test tomorrow as long as you find some other test, and there are tests that you can develop yourself. You already have, you can adapt it to Common Core, no big deal. Or you can buy it from ACT or somebody else. So at least all those tests and all the strictures you can bail out tomorrow, just find something replacing. From standards, it's a bit more complex because you got the waivers in the state. And if you withdraw from the standards, you have to replace them by standards that are college ready. Now, Common Core is not college ready, they show, but they are accepted as college ready by Fiat, because we said so, even though they are not. All the others actually have to prove that their state colleges say, the majority, not all of them, say, yeah, this, whatever you come up with is good enough for us as an entry for our freshmen, so fine. If they have it, you can do it. So you have to go to prior standards or augmented prior standards or somebody else's standard and get your colleges basically say, yeah, that's good enough. And then you can bail out.
Post Common Core, but that's what I'm kind of wondering. If a school district continued to teach what Idaho's teaching now, can they pass the Common Core math standards that are coming down?
So you mean, can you just teach whatever you teach but pass the Common Core test?
Yes. As a homeschooler, I don't have to follow any state curriculum.
It's hard to answer. You could argue that, if you know more than the Common Core asks for on the test, you should do well. I mentioned that, 8th grade students that take algebra will be exposed to regular 8th grade maths. You say, well, what's the big deal? They will score in the top. Maybe, maybe not. Depends what they focus in the questions about. First, there is an issue of memory. Remember, you forget certain things if you don't spend it. They actually call it malpractice to test on something you didn't study in the year that you're supposed to be responsible for. But forget about this part. If they were to ask about regular maths, what you would think of, I believe in as regular maths, and I would think as regular maths, it probably will work anyway. The problem is that if you go to Smarter Balance, they said very clearly, hold it, let me show something. Here, I want to show. Come on. What's going on here? Sorry, this was for okay, here we ended. Okay. The Common Core standards for mathematics have something called the standards for mathematical practice. There are 8 standards, and here they are, all the 8 of them, no more, no less. They are supposed to cut across the grades. The standard document, which is about 80 pages long, spends 3 pages on this standard, and that's it. All the other 77 pages or so, 75 pages are on the content of each grade. Makes sense. Except that the Common Core curriculum development and the Common Core Assessment Consortium, in Smarter Balance in particular, say they will focus on those. The content will be 1, 2 grade level behind, that's fine. We don't care about the content. They focus on this. Now, this is nothing wrong with it. This is almost motherhood and apple pie. I don't believe any textbook, any curriculum, any mathematical program ever would have any issue with any of those. But they don't make up a curriculum, a program. They are just, well, those are good things to have. How do you develop them? What do you pay attention to? So the Smarter Balance say, we'll pay attention to how you solve. Talk about your solution. Show us 7 different ways to skin the cat, not just skin it. And even if you skin it badly or incorrectly, it doesn't matter as long as you talk about it well. So, will your child succeed? I have no idea.
Could I mention one thing? In Indiana, the anti-Common Core movement got started there with 2 mothers who had 3rd graders in Catholic school. But because they were voucher schools and they accepted voucher kids, under Indiana law, they had to take the Common Core test. They had to give the test. So, 3rd grade test. this wasn't the test that they're actually going to be taking, but the way they teach it in the lower grades is the fuzzy math. They're getting away. I think almost everybody in this room would flunk a third grade test because of the way they teach it. The test was, one of the questions for a third grader was, Bridge A is 430 feet long, Bridge B is 410 feet long. Which one is longer? How do you know? How do you know? You've got to explain everything. So the little girl writes, Bridge A is longer, I know, because 430 is greater than 410. That was marked wrong because she did not do it correctly. She had to use the sort of weird alternative ways of doing it. And if that's what the Common Core test wants you to do, and so the parents went and talked to the principal, and he said, I'm sorry, I know you don't like it this way, I know that you don't understand it and the kids don't understand it, but we have to teach it this way because this is the way it will be on the test.
Let me give you an example of Common Core Smarter Balance test. Here is a test. This is a grade 11 example. I don't think it takes Algebra 2, Algebra 1. It doesn't take much to do. It's basically a table to understand some basic things. And if you read it, you say, oh, it's a pain in the butt. Yeah, I can do it. It takes a couple of minutes, and I'll write it down. And you have to type in the answers, you know. The problem with these kind of questions, as I said, it's about how you approach them, not about the content, because I said content is below grade. They kind of said, we don't worry about the content. Anybody can do content. Yeah, right. What would happen if somebody would answer this kind of question? Carby must be the one ending up across the list. Otherwise, the question must have been, was provided, how much at most can Tony drive? Because clearly, if Tony drives a lot, it will become cheaper. But you say the minimum, so already he had to cross the line, otherwise you had to provide the most. So guess what? I don't have to solve it. This is a very smart kid. He knows everything. He'll get 0. He didn't do the calculation, he didn't answer the rubric, he didn't show this and didn't show that. He knew more than the teacher probably knew, because the teacher made the question wrong. The question was basically giving the answer. If the question has to have an answer, it has to be Tony. It has to be Carby. So this is an example. You try to reach the sky, but you don't know how to walk it. This is their own sample, grade 11. Wow. Calculus question. Anyway, I didn't go. I have a lot of slides, but okay, guys, thank you for your time.